Multiple equilibria problems have two components. One, when you manipulate, it's kind of like Hess's law in that you're manipulating reactions and manipulating the value that goes with them, and you're combining reactions to find some new reaction. What's different about it is how the manipulation works and how it changes the value. So for example, if I give you 2N2 plus O2 is an equilibrium with 2N2O, if I were to write the equilibrium expression, that's not what it would be. N2O squared over N2 squared times O2. And this one has a value of 10. For this second reaction, what would change in it is rather than my numerator being to the second power, it's to the fourth. And the denominator, rather than being exponents of 2 and 1, is now 4 and 2. So it's as if I took this entire thing and squared it to get that. Therefore, what I'm going to do is I'm going to take the k value associated with that, which is 10, and square it, which tells me k for this reaction would be 100. So if I'm doubling a reaction, I'm squaring k. If I'm tripling a reaction, I'm cubing k. If I'm dividing a reaction by 2, I'll be square rooting k. From here to here, I want to look at what I did to the reaction. It looks like I reversed the reaction. So if I were writing the k for this, what used to be on the bottom is now in the numerator, and vice versa. So going from there to there, it got flipped. In other words, numerator and denominator switched. Therefore, I need to take the inverse of that number. So my new k is 1 over my old k, which would be 0.1. If I'm combining reactions, something different happens. Let's take a look at my equilibrium expressions here. This would be C times D over A times B. I'm too lazy for brackets at the moment. This would be E times F over C times D. If I combined these reactions, cancel, cancel, I get this. If I wrote the equilibrium expression for this, it would be EF over AB. Now I want to figure out how does this reaction and this reaction's K expressions relate to this. So we know which ones we're talking about. I'm going to call those K1 and K2, and I'm going to call that K3. If I take K1 and I multiply it by K2, what we'll end up with so when I'm adding two reactions together, I'm going to multiply their Ks in order to get the K for the overall reaction. Let's see what this looks like if we're doing both things at once, manipulating reactions and combining. So you're given two reactions and you're asked to find K for this goal reaction. So somewhat like Hess's law, I want to figure out what I need to do to each reaction so that it'll add up to the overall. So starting with reaction 1 here, what does it have in common with my goal reaction? SO2. Do I have the correct number of them? No. Is it on the correct side of the reaction? No. So this reaction is going to need to be reversed and divided by 2, which will give me SO2 plus 1/2 O2 is in equilibrium with 2 SO3. Sorry, just SO3. So what do I do to my K value? For the reversal, I'm going to flip it. And for the dividing by 2, I'm going to take the square root of the value. So the K for this is going to be 1 over 2.3 times 10 to the negative 7th, square root of that. It doesn't matter whether you square root first or flip first, both work. For my second reaction, what does it have in common with my goal? These. Correct number? No. Correct side? Yes. So all I have to do for this reaction is divide by 2, but keep them on the same side. So then what I'm going to do for that value is, since I divided the reaction by 2, I'm square rooting. These will combine to give me my overall reaction. So then I'm going to multiply those two K's together. So I'm going to have the square root of 1 over 2.3 times 10 to the negative 7 times the square root of 1.4 times 10 to the negative 7th. And so 1.4 e negative 7 square root of that divided by 2.3 times 10 to the negative 7th square root. I can't do this on my phone. I don't have my calculator with me. And that will give me the answer to the problem. You have practice problems on multiple or on finding K from graphs. It also connects to the idea of manipulating reactions and manipulating Ks. And if you have any questions, I will see you next class.